Welcome, fellow explorers, to a world where colossal creatures reign supreme. Today, we're embarking on an extraordinary journey into the fascinating realms of Godzilla and King Kong, two of the most iconic monsters in cinematic history. These titans of the silver screen have captivated audiences for decades, their stories woven into the fabric of global pop culture. We'll be delving deep into the biology and physics of these legendary beasts, asking questions that might seem outlandish, yet intriguing. Could a creature as massive as Godzilla really exist? And just how strong would King Kong need to be to scale skyscrapers? Strap in, because we're about to find out. But before we dive in, let's take a moment to appreciate the sheer creativity and imagination that went into creating these creatures. From Godzilla's design, inspired by various dinosaurs including the Tyrannosaurus rex and the iguanodon, to the iconic roar that was originally created using a resin-coated glove rubbed against a double bass, the world of monster movies is full of fascinating trivia. We'll also be taking a look at the cultural impact of these creatures, and how they've captured the imagination of audiences around the world. We'll discuss the origins of these characters, their impact on popular culture, and how they've evolved over time. We'll also delve into the science behind their creation, exploring the principles of biology and physics that underpin their existence. First up, we have Godzilla, often referred to as the King of the Monsters. A creature of immense proportions, Godzilla towers over the tallest buildings, his size and weight truly awe-inspiring. But did you know that Godzilla's height has varied across films, ranging from 50 meters to a staggering 120 meters? That's taller than the Statue of Liberty. Now, let's take a moment to consider what this means. Imagine a creature so large that it could look down on the Statue of Liberty. It's a mind-boggling thought, isn't it? But that's not all. Godzilla's weight is equally impressive. Estimates put his weight at around 20,000 tons. That's as heavy as a cruise ship. But what does this mean in terms of his impact on the environment? How would a creature of this size interact with the world around it? Let's explore. We'll discuss the implications of Godzilla's size and weight on his environment, how he would move, and how he would interact with the world around him. We'll also delve into the science of gigantism, exploring how and why creatures grow to such immense sizes. We'll look at examples from the natural world, comparing Godzilla's size and weight to that of real-world animals and exploring the challenges and advantages that come with such immense size. One of his most iconic traits is his ability to breathe atomic fire, a testament to his extraordinary biology. This atomic breath, while fictional, is often compared to nuclear radiation, highlighting the creature's origins as a metaphor for nuclear weapons. It's a chilling reminder of the destructive power of nuclear energy, wrapped up in the form of a giant monster. But how does this power work? Let's delve deeper into the science of atomic breath. We'll explore the concept of energy conversion and the potential mechanisms that could generate such a devastating attack. We'll discuss the role of specialized organs and glands that might facilitate this process. Additionally, we'll examine the potential risks and consequences of harnessing such immense power. As we explore Godzilla's regenerative abilities, we'll examine the fascinating field of regenerative medicine and the advancements being made in tissue regeneration. We'll also discuss the biological processes that enable organisms to heal and regenerate, drawing parallels between real-life examples and the fantastical abilities of Godzilla. This exploration will shed light on the scientific possibilities and limitations of regeneration in the animal kingdom. But could a creature of such size and abilities really exist? Godzilla's size and weight would make him incredibly dense, which would likely result in him sinking rather than crushing buildings. It's a fascinating thought, isn't it? Let's delve deeper into the science behind Godzilla's biology to understand how his physiology could support his massive form. We'll explore concepts such as skeletal structure, muscular adaptations, and physiological systems that might allow Godzilla to move and thrive. Additionally, we'll investigate the mechanisms that could protect Godzilla's tissues from the immense pressures they would experience. We'll consider unique adaptations, such as reinforced bone structures and shock-absorbing tissues. By examining the principles of biomechanics and structural engineering, we can gain insights into how Godzilla's biology could withstand the forces exerted upon it. We'll also discuss the potential metabolic requirements of a creature of Godzilla's size, examining the energetic needs and the ecological implications of sustaining such a colossal organism. Through this exploration, we'll gain a deeper appreciation for the complexities of Godzilla's biology and the scientific possibilities that underlie his existence. Now, let's turn our attention to another titan of the monster world, King Kong. Known for his immense strength and agility, King Kong is a creature that defies the laws of physics. Despite his size, King Kong is incredibly agile, capable of climbing skyscrapers with ease. This ability is reminiscent of actual primates' ability to climb trees, although on a much larger scale. But how does he do it? How can a creature of his size move with such agility and speed? It's a question that has puzzled scientists and fans alike. In this part, we'll explore the biomechanical marvels that enable King Kong's incredible feats. We'll dive into the study of muscle structure, leverage, and joint mechanics to understand how King Kong's physiology allows him to navigate his environment. We'll also examine the adaptations in his musculoskeletal system that enable him to generate immense force and exert remarkable control over his movements. By dissecting the science behind primate locomotion and scaling it up to King Kong's scale, we'll uncover the secrets behind his agility and strength. Get ready to explore the fascinating world of biomechanics and unlock the mysteries of King Kong's astonishing abilities. King Kong's strength and agility, despite his size, defy the square-cube law, a principle in physics that describes how the volume of an object grows faster than its surface area. It's a law that governs the natural world, but in the world of King Kong, it's a rule that's made to be broken. But what kind of strength would King Kong need to leap great distances or resist damage from bullets? King Kong's resistance to bullets and other attacks suggests a high level of physical durability, a trait that is seen in some large animals like elephants and rhinos. However, King Kong takes it to a whole new level. His strength and durability are off the charts, even by monster standards. In this part, we'll dive into the physics behind King Kong's incredible feats. We'll explore the principles of force, momentum, and energy to understand the extraordinary physical abilities exhibited by King Kong. We'll discuss concepts such as muscle strength, impact resistance, and structural stability, unraveling the secrets behind King Kong's seemingly superhuman abilities. By examining the science of materials and the principles of biomechanics, we'll gain insights into the remarkable feats King Kong accomplishes. Prepare to be astounded as we uncover the hidden physics that make King Kong a true force to be reckoned with. So, there you have it. A theoretical exploration into the biology of Godzilla and the physics of King Kong. While these creatures may be the stuff of fiction, the science behind them is fascinating. We've journeyed through the world of colossal creatures, delved into the science behind their incredible feats, and uncovered some fascinating trivia along the way. From Godzilla's astounding size and weight to King Kong's awe-inspiring strength and agility, we've explored the wonders of their biology and the physics that govern their actions. But these creatures are more than just fictional beings on the silver screen, they hold a special place in our collective imagination. Their stories and adventures have captivated audiences worldwide, leaving an indelible mark on popular culture. Throughout our exploration, we've touched upon the connections between these monsters and real-world science. We've examined concepts such as gigantism, radiation biology, regeneration, biomechanics, and more. By drawing parallels between the fantastical and the factual, we've deepened our understanding of the natural world and the incredible possibilities that lie within it. We've seen how elements of biology and physics are woven into the fabric of these creatures' existence, challenging our preconceptions and igniting our sense of wonder. But our journey doesn't end here. The worlds of Godzilla and King Kong continue to evolve, with new stories, adaptations, and scientific advancements on the horizon. As science progresses, who knows what new insights and discoveries await us? So, keep your eyes on the horizon, for the realm of monstrous wonders is ever expanding. Thank you for joining us on this extraordinary expedition into the biology of Godzilla and the physics of King Kong. We hope you've enjoyed this exploration as much as we have. Remember, the intersection of science and imagination is a place of endless fascination. Until next time, keep exploring, keep questioning, and keep marveling at the wonders of the world around us. And with that, we've reached the end of our journey, coming in at a delightful 10 minutes of awe-inspiring knowledge and entertainment.